All right, so practice test of 4-6, 4-7, and 4-8. It's only 3 sections, but we had that nice long 10-day break for you in there, which hopefully, once you get rolling through this, you'll go, oh yeah, now I remember all that stuff. But let's see how it goes. So on the test, it's just going to say, solve by using square roots. Is that enough to tell you what to do? Take a look at number 1. Thoughts? Add 81 to both sides. Sounds like a good way to start. Square root of both sides. I would lose points. Yes, plus or minus. Remember, when we physically write that square root symbol, we have to write the 2 answers that are possible, which are plus or minus 9. Yeah, absolutely, because there's 2 answers and you only gave 1. Alrighty, take a look at number 2. What do you think? Okay, let's try it. Let's use the same method we did on this other one. Okay, hang on. You're a step ahead, Train. How do you undo squaring? Can't square root a negative. So, right, we're going to need the square root of -1. And then the person that said 9 and 2, Paige, was that you? That's also right. Yeah, because we have to change that square root of -1 to I, right? Okay. So is there anything else that's going to end up nice out of all of those we just put there? The 3? Plus or minus 3 square roots of 2. I. Remember, don't let your square root get carried away and make it look like your I is under your square root, because it's not. So plus or minus 3 square roots of 2i. So I is going to happen on this test. We talked about imaginaries. All right, now talk about going way back in your memory banks, huh? Completing the square. Ooh. What value completes the square? Looking at 2 things. First of all, is there a 1 in front of the x squared? That is fantastic, because to complete the square, it has to be a 1. Now we have to remember the little formula to complete the square. B over 2 squared. Yep, that's it, that little b over 2 squared. So -12 divided by 2 squared is -6 squared. What's that? 36. Yeah, don't put it in a calculator. Come up with it in your noggin. -6 times -6. If you want to use a calculator, just don't forget to do parentheses. Otherwise, the calculator will tell you -36. We know that's not true because it has to be a perfect square, and perfect squares are positive. So 36. Now, once we remember b over 2 squared, we have to use it to do these 2. Alrighty. X squared plus 16x minus 7 equals 0. Does that have a 1 in front of the squared term? That's a plus. That means less work. Is -7 a perfect square? Well, then that's not helpful. So what do we do with it? Yeah, move it over. Move it over. It wasn't helpful. It's not a perfect square. We need the number that will be, bless you, helpful. Yep. 16 over 2 squared. And that's 8 squared, which is what? Wow. Wow, 64. All right, so we're going to have to add a 64. And yeah, I'm showing an extra step here for people that are gone so they can see what we did. All right, well, we know what 7 plus 64 is. We're not really happy with it, but we know what it is. It is? Yeah, 71. Well, I'm not happy about that because it's not a perfect square, but we'll deal with that when the time comes. This is now a perfect square trinomial, so we can write it as a binomial squared. But what would go in there? X plus, what did we square to get 64? 8. Now, test-taking strategy. You get to this point, think, oh, what did we do just before this? We had to solve by taking square roots. What would the step be here? Square root, both sides. And that's where we're not going to forget. It's plus or minus the square root of 71. Okay. Square root of 71 is not a perfect square, right? Let's see. You think we have any that'll work in it, though? Well, 64 would be the next smallest one below 71. 64 is not going into 71. Don't even bother, right? Okay. So 7 squared is 49. 49 going to go into 71 nicely? 36. And you could try them if you're sitting there thinking, I don't know, Cedar Home, I'd punch them in. Well, oops, I guess I'd have to punch it in correctly. 64 doesn't work. 49 doesn't work. 36, not 26, doesn't work. 25, wouldn't even bother checking, right? Because it doesn't end in a 5 or a 0. The 71 doesn't, so what's the point? 16? No. 9? No. 4? No. What does that mean? Yeah, we can't. We have to just leave it a really ugly square root of 71, but that's okay. Less work, right? Okay. Not done yet, though, because I didn't solve for x. How do you get x alone? Should I put that together and say plus or minus the square root of 79? No, one's a square root and one's not. Those are two perfect answers right there. Negative 8 plus the square root of 71 and negative 8 minus the square root of 71. And that's where we would stop. And we'd say they are perfect. That one's done. Take a look at B. To complete the square, we have to have a 1 in front of the x squared. Do we? Uh-oh. How are we going to get that out of there? How? Yes and no. It will take 2 steps if we factor it. How can we get rid of that negative in front of the x squared? Divide everything by negative 1. Good news for the right side, it's still going to be 0. So basically all we're doing is changing all the signs when we divide it by a negative 1, but that's good. Alrighty, did that just happen to be a perfect square trinomial? What number messes it up? Yeah, where do we put it? Other side. Oops, I didn't leave enough room for the number that does work. How do we get that nice number again? B over 2 squared. So 14 divided by 2 squared. That's 7 squared, which is 49. And that's always going to be a plus because that has to be a perfect square. 26 plus 49. 75. And what do we put in the parentheses? Good, x plus 7. Next step. Square rooty toot toot. Square root of 75. Something we could do with that? 5 square roots of 3. So it's square root of 25 and square root of 3. Can we put them together? No. Silly Cedar Home. Of course not. One has a square root of 3 and the other one doesn't. Those are not like terms. Again, two perfect answers. Negative 7 plus 5 square roots of 3 and negative 7 minus 5 square roots of 3. Beautiful. So, big deal with completing the square that you have a 1 in front of your x squared. Now, this is write it in vertex form. Boy, that's been a while. We better write down what vertex form is. That's that thing that uses AH and K. Y equals A, quantity x minus h squared, plus K. So I start to think, why would that be right here after we just completed the, oh, we have to complete the square. So we're going to have to complete the square in order to get this little x minus h squared piece here. I don't think the right side of this is a perfect square. So what should we do? What number's bad over there because it's not a perfect square? So let's move it over to the other side. Now you can't drop the y. The y was there, so we have to keep it. Oh, I'm going to need some space, though, for a nice number. Because we need the nice number that's going to complete the square. Find it. Tell your chicken wing elbow partner what that number is, please. Everybody agree? 16? 8 divided by 2 squared is 4 squared, which is 16. So now it's going to say y plus 27 equals something squared. What's the something? X plus 4, yeah. And that almost looks like vertex form. If I could just get this y by itself, then it'll be there. Subtract 27 from both sides. Suppose we should take 4 minus 27 and get negative 23? No. One's in a squared. And one's not. So we just have to tuck it back there. Y equals the quantity x plus 4 squared minus 27. Follow-up question, since this has been quite a while. Let's just say there were a little blank after that that said vertex. Would we remember? It is. Good, Eric. Good. Negative 4. And yes, the one with the x is always the opposite. So, like I said, it's just a good reminder in case there's a little follow-up, you know. The next one is a little tougher. Take a look at B. Why is this one a little tougher? X squared is not 1x squared. Rats! So the question is, should we move the 4 over first, or should we divide by 2 first? And the answer is, it doesn't matter. So which one do you want to do first? Divide by 2? Now that means we've got a little fraction over on the left-hand side. Don't let that worry you too much. Yeah, instead of factoring, we'll just divide everything by 2. Is it a perfect square over there on the right now? Oh, one number's keeping it from being. Doggone it. All right, we'll have to add the 2. I better change colors, though. Now here's where it gets a little weird. You could just leave it y over 2 plus 2 if you don't want to deal with the fractions. But if you're not too afraid of fractions, you could say, let's see, right now it's 2 over 1. I need them to be 2's on the bottom. So I'm going to have to do this to make that happen. And then you could put them together. And we're not done, but that's a good start. Like I said, you wouldn't have to. You could keep it y over 2 plus 2, because we've got another step that's going to take place here. Because we didn't complete the square yet, did we? Find the number that'll make this work. First, let me back up, because I want to do it the way you would do it. Would you put the fraction together, or would you just keep the 2? Well, then let's keep the 2. Let's do that. Did you already find it? What is it? It's a 4. 4 divided by 2 squared is 2 squared, which is 4. Now, we definitely would put the 2 and the 4 together on the left, because that would just be weird to leave that sitting like that. And now we do have a perfect square trinomial on the other side. X plus 2. Everybody agree? And now all we have to do is move the numbers from the left side back over to the right side. So what's going to go first? Yep, subtract 6 from both sides. We already know we can't put that in the parentheses. And now how do you get rid of dividing by 2? Multiply what? And everything in the whole equation. So you need to look at this and remember that terms are separated by pluses or minuses. So we're going to have to multiply all of this by 2. So it'll be 2 times the quantity x plus 2 squared, that's going to be in our parentheses there, minus 12. Every term has to be multiplied by that. That one's a little tougher than what you're going to have to do on the test. But I did that so that you could see one and know, okay, this isn't as bad as it seems. I would expect to have a negative in front of the x squared for one of them, because at the very least we want to know that you remember it has to have a 1 in front of the x squared. All right, so that was all about solving quadratics by completing the square. And this one changes gears, but it's nice because it actually changes gears in the directions too. It tells us, solve using the quadratic formula. Leave answers in simplified radical form, so no nasty decimals. Just leave them simplified. Alrighty. I know it's been a long time, but take a look at A. Does that look ready to go for the quadratic formula? Right, it has to have a 0. So let's subtract the 1. Looks like that. Does that look more ready? Yeah, because when you solve, you're finding the zeros, so you need a 0. And then let's write down A, B, and C so we don't get messed up. A is, B is, C is. Is a little song playing in your head yet? X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. All right, so let's put them in. What would we start with? 5, right. Negative of negative 5 is 5. Plus or minus, remember, do this one in your head, otherwise if you put it in the calculator, you might come out wrong. Negative 5 squared, 25. Minus 4 times 3 times negative 1. And what do we put on the bottom? 6. 2 times 3 is 6. Again, there's 3 little steps here we're doing in our head, but don't try to do all of this underneath the square root in your noggin, because that usually doesn't go well. There's just too much going on. So now, if you wanted to, you could grab a calculator to do what's underneath there, or you could do it in your noggin. And negative 4 times 3 is negative 12, but negative 12 plus 1. Negative 12 times negative 1 is positive 12. So it's 25 plus 12, which is 37. And again, you can do that in a calculator if you want to. In fact, just to show everybody, 25 minus, and then use parentheses, 4 times 3 times negative 1. You get 37. So there it is. Square root of 37. Nothing? 25 is not working, 16 is not going to work, 9, 4, not a thing? Hey, we're done with that one then. That is in simplest form. There's nothing else we can do with it. All right. B looks like a whole lot of messed up, doesn't it? Ideas. Yeah, I would too. I like my first term to be positive anyway, and I know that's more of a completing the square thing, but just feel better when that number is positive. So A is 1, B is 6, and C is negative 5. Sing a little song in your head. X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. What's going in the front? Negative 6 plus or minus, what's B squared? 36 minus 4 times 1 times negative 5 all over 2. X equals negative 6 plus or minus the square root of 56. Negative 4 times 1 is negative 4. Negative 4 times negative 5 is 20. 36 plus 20 is 56. 56. Perfect squares that go into 56. Nope. What else would you try? Gotta be perfect squares. 14 times. Now let's check and make sure, though, that we got the biggest one. 14. Well, the only ones that we would have that could possibly divide into 14 nicely, and we could keep going with this, would be 9 and 4. 9 or 4 go into 14 nicely. So we did find this, the biggest one. That was the best we could do. Now, one of those is nice, right? Which one? Square root of 4 is 2. Is this one done? No. Everybody see all the 2's? Okay, so let's pull a 2 out of the top by factoring. And that way we'll be able to do the canceling, because remember, canceling is a form of division. We need to see the multiplication. Well, it didn't end up quite so ugly. Negative 3 plus or minus the square root of 14. Not bad at all. So notice the directions said, hey, switch gears, go to the quadratic formula now. Ready to move on? Anybody need more time? Evaluate the discriminant. Discriminant, what's that again? What's the little formula for the discriminant? We just saw it. If we know the song, it's the part that goes under the square root piece. B squared minus 4ac. That's the discriminant. So evaluate the discriminant and then determine how many and what type of solutions each of these has. Okay, well, is A ready to go? And why do I say that? Because it has to have a 0 on one side. Remember, this is part of the quadratic formula, so it has to have a 0. So this one's good? All right. A is negative 3, B is negative 12, and C is 1. And we just need B squared minus 4AC. So what's B squared? Minus 4 times negative 3 times 1. Again, do it in your noggin, do it on the calculator. Doesn't matter. Negative 4 times negative 3 is 12. 12 times 1 is 12. 144 plus 12. There's the discriminant. So we put that in the blank. Now we have to remember, does that mean it has 2 reals, 1 real, or 2 imaginaries? 2 reals. It's positive, so it has 2 real solutions. So positive is 2 reals, 0 is 1 real, and negative is 2 imaginaries. Alrighty, is B good to go? Move anything over? Nope. So A is 4, B is 4, and C is 1. What's B squared? 16 minus 4 times 1. Hey, wait a minute. Negative 4 times 4 is negative 16, and negative 16 times 1 is negative 16. 16 minus 16. How many and what type? 1 real. 1 real. Is C ready to plop in the formula? It is. It has a 0. What's B squared? 64 minus 4 times 7. 4 times 4 is negative 16. Negative 16 times 7. Oops, I forgot the negative. Oh. 64 minus 112. Negative 48. How many and what type? 2 imaginaries. Because imaginaries always come in pairs. So again, positive, 2 reals. 0, 1 real. Negative, 2 imaginaries. Cool. That wasn't a lot of work. Little b squared minus 4ac. Oh no, a word problem. Okay, test-taking strategy. They switched gears a while back and did the quadratic formula. The discriminant was a part of the quadratic formula. Chances are pretty good we're going to have to use the discriminant and or the quadratic formula. Susie throws a baseball up into the air. Oh, well, that makes sense. That's going to be a parabola, which is exactly what we're doing with quadratics. The ball leaves your hand when it's 4 feet above the ground. The height h of the ball in feet can be written as a function of time t in seconds as, well, look at that. They gave us the whole formula and everything. Will the ball reach a height of 30 feet? Where should the 30 go? Here's our formula. What does the 30 represent? Height. It's got to go there. All right, so let's see. So all I have to know is, yes or no, is this going to happen or not? Well, I don't need the whole quadratic formula for that. I just need to know if it's going to come out with real answers. What did we just do to check and see if stuff was going to have real answers? Okay, so is this ready for the discriminant? No, let's get the 30 over. Got to have a 0. So we've got negative 16t squared plus 40t minus 26. All right. A is negative 16, B is 40, and C is negative 26. So we might want to use a calculator for this, but 40 times 40 is 1600. Minus 4 times negative 16 times negative 26. That doesn't look like a negative 26. So let's see what that comes out to be. A big mess there. 1600 minus parentheses 4 times negative 16 times negative 26. Negative 64. So what does that mean? Two imaginaries. So is this going to happen in the real world? No. So I'm just going to write 2 imaginaries, and I'll just do it. I-M-A-G. So the answer to their question, nope. Isn't going to happen. Oh, they switched it on us. When will it be 15? Notice it doesn't say, can it happen? It says, when will it be 15? So where does the 15 go? Is 15 time or is it height? It's height. What do you suppose we should do with that? So far, so good? Now, it didn't say which method we had to use, but remember, the test-taking strategy was probably best to use the quadratic formula. And if we really wanted to use completing the square, this one would be messy. Does everybody see this negative 16 up here? Yikes. Dividing that whole thing by negative 16, that would be nasty. So instead, let's use the quadratic formula and see what we get. Should I sing the song, or can we do it without it this time? Okay, so what number is going in front? Negative 40. We already know what 40 squared is from doing the discriminant, right? But they did change one of those numbers, so that's going to redo this. On the bottom, negative 32. All right, let's see what obnoxious number we can get underneath that square root thing, huh? So we have 1600 minus parentheses 4 times negative 16 times negative 11. 896. Now I have to think. If I'm going to tell somebody when this ball was up in the air, do I really want to simplify that square root, or do I want to just get calculator answers? Well, would you tell somebody it was at negative 40 plus the square root of 896, all divided by negative 32 seconds? So we better punch her in. So we've got negative 40 plus the square root of 896, and then I'm going to press enter so the calculator gets all of that and divides it by negative 32. And that is about 0.31 seconds. And then negative 40 minus second square root of 896. And divided by negative 32. About 2.19 seconds. So it's just punching it in twice as negative 40 plus the square root of 896. If you want, pardon me, if you wanted to punch this in all at once, you'd have to do parentheses for the top. And that's usually why I don't do it that way. You get the same answers. It's just a lot of parentheses to keep track of if you want to punch it in as one. Alrighty. Looks like there's something we didn't deal with yet, and I see it on the back page. Imaginaries. Da, 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 da. Alrighty. So, what is the problem with the square root of negative 25? It's got a negative. Because without it, we would have said, it's 5. But it's not 5 because of the negative. So what do we use for the square root of negative 1? I. It will be 5. Oh, shoot. I put a square root on that. So let me do it in 2 steps. I5 just doesn't feel right. It shouldn't. We should have the number in front. So 5i. Number 10. Got square root of negative 1, right? $72. Bigger. 36 and 2. Now, Paige, that doesn't mean you wouldn't have gotten there, because you probably would have noticed, oh, look, I got an 8. A 4 goes into 8, you know. So we have I and a 6 and a square root of 2. So 6 square roots of 2 and then an I hanging out in the back. Yeah, Trey. You would lose points because of that right there. In standard form, the I has to go in the back. Alrighty. Looking at number 11. Oh, we might have to finish these tomorrow. Well, let's do this one real quick, then we'll finish it up. What do you see? This is subtraction. Is that negative in between there important? Yes, we have to distribute the negative. And then we can combine like terms. So what would we get? Would that be in standard form? We need the I in the back. Like so. Looking at 12. Is that add, subtract, multiply, or divide? Ooh, then that means we could just drop the parentheses. So what do we get? And there it is. Okay, so we have to do our multiplying and our dividing tomorrow, huh? Just ran out of time. And like I said, we'll finish this up with our multiplying and dividing. And tomorrow will be a work day on the review assignment.